How do you steal a Soviet gunship from one of the most dangerous deserts on Earth without alerting the enemy or losing a single aircraft? The answer: meticulous rehearsal. Before ever touching Libyan sand, the 161st Night Stalkers rehearsed with 6 giant water blivets until they could sling load a Heinz weight blindfolded. What looked like insanity was actually science, a covert logistics experiment that would redefine how special operations aviation thought about moving impossible cargo. During the late Cold War, Western intelligence analysts found themselves staring at a helicopter they could neither match nor properly study: the Soviet Mi-24. Known to export customers as the Mi-25, it carried the dimensions and lethality of a small gunship, yet behind its armored cockpit sat a compartment large enough for 8 troops in full gear. That alone broke with the Western formula. The American UH-1 Huey and even the later Cobra variants separated transport from attack roles, but this Soviet design merged them, granting flexibility few strategists in the Pentagon could ignore. The Hind-D's construction philosophy embodied an entirely different view of how helicopters could fight. It was heavy, close to 18,000 pounds fully armed, and protected by armor plating that could deflect small arms fire across most of the fuselage. The designers at Mill accepted speed penalties in exchange for survivability. Its stub wings added lift and space for rockets or anti-tank missiles without relying entirely on rotor thrust. In practical terms, it operated more like a flying infantry fighting vehicle than a conventional utility helicopter. Western analysts began to wonder how much of its airframe used composite reinforcement and whether the rotor system relied on novel metallurgy to offset stress under such weight. By the early 1980s, the United States and its allies had gleaned observational data from Ethiopia, Afghanistan, and Angola, where Soviet advisors had deployed Hinds in significant numbers. They could record its noise profile and flight envelope, but they could not examine the components that mattered most: the hydraulic layout, transmission gearing, or blade construction. Rumors circulated that its flight control servos resisted heat distortion far beyond Western norms. Without material evidence, those claims remained speculation. Intelligence branches began issuing discreet requests to locate a recoverable airframe, yet almost all field leads turned out to be wrecks, stripped hulks, or export versions so damaged that their systems could not be reconstructed. Then regional politics intervened. Following the 1987 defeat of Libyan forces in northern Chad, Chadian troops discovered a largely intact Libyan Mi-25 Hind-D at a remote airfield called Wadi Dome. It had sustained minor desert damage but remained complete from engine nacelles to tail rotor. For the CIA and Department of Defense, this represented the first genuine chance to evaluate Soviet helicopter engineering up close. The conditions were both ideal and hazardous. Ideal in that no Soviet technicians could retrieve it. Hazardous because the airfield lay within range of potential Libyan patrols. Under the harsh Sahel sun, the green and tan camouflage faded while its tires baked into the concrete ramp. Sand accumulated in the intakes, yet the structure appeared solid, a 17,000-pound relic waiting to be lifted. What it promised was not simply new data, but a full cross-section of Soviet design logic: armor composition, electronics hardening, and manufacturing quality. For Western engineers, that helicopter became a benchmark, the holy grail of rotary wing intelligence, valuable enough to justify an international operation simply to move it. The challenge no longer concerned political secrecy alone, but mechanical feasibility. Could anyone transport that massive airframe out of a desert combat zone without disassembly? The answer depended on testing whether a CH-47 Chinook could lift it at all. Before a single rotor touched the sand of Chad, the mission had already taken place in another desert, quietly, with no Soviet helicopter in sight. The operation known as Mount Hope, 2 unfolded months earlier in New Mexico, where the 161st Special Operations Aviation Regiment replicated every step of the extraction under controlled conditions. This was not a training exercise for pilots alone. It was an engineering validation disguised as flight training. The Army wanted a binary answer. Could a CH-47 Chinook safely lift a dead weight near 18,000 pounds at night without losing control? The logic behind the exercise was simple enough, yet technically unforgiving. A sling load of that magnitude sat near the upper limit of the Chinook's tolerance, especially at high temperatures and low air density. Engineers built the target weight using 6 enormous water-filled blivets arranged to reproduce the Hind-D's center of gravity. This approximation tested how the helicopter would behave when a bulky, asymmetric load hung far below its main suspension beam. Each flight studied minor variables: oscillation frequency, rate of swing damping, and control sensitivity, until the data converged on a stable profile. Flying low at night added another layer of precision. Crews operated under night vision goggles, practicing techniques they would later use in Africa, where moonlight and sandstorms would limit visibility. The pilots learned to anticipate the inertia of the hanging mass at every collective input. Even small corrections could amplify vibration through the sling cables, so they spent hours refining hover stabilization using tiny, predictable control shifts. Rotary wing specialists reviewed the results after each sortie, comparing the energy transfer patterns captured by onboard sensors to computer models prepared by Army engineers. Heat remained the constant adversary. In the New Mexico environment, air density reduced lift, forcing heavier power settings and higher fuel consumption. Prolonged hover at these limits risked both engine overtemperature and rotor harmonics severe enough to damage the transmission. To counter it, planning teams calculated refueling intervals down to the minute, treating every gallon as mission-critical payload. The loadmasters also updated the sling harness design after each flight, adding redundant, quick-release points and improving alignment collars to prevent cable twist under torque. Coordination across disciplines marked Mount Hope II's real achievement. Flight crews, engineers, and logistics officers operated as a single test cell, iterating constantly on material solutions to what was, effectively, an aeromechanical riddle. By the end of the trials, they had integrated a full procedural chain, from attachment under field lighting to in-air release during simulated emergencies. Every subsystem, from the hydraulic dampers on the harness bars to the emergency cutaway levers inside the Chinook cabin, had been proof tested. In practical terms, the experiment moved the idea of stealing a Soviet helicopter from improbable to calculable. It turned theoretical schematics into demonstrated flight performance. When the final assessment confirmed that the configuration could bear and balance 18,000 pounds reliably, planners knew the real mission no longer rested on conjecture. The rehearsal had drawn its map. The next iteration would have to follow that route under live conditions. Mount Hope III awaited in an actual war zone. When two CH-47 Chinooks dropped into Chad under French protection, they weren't just hauling metal. They were moving a Soviet secret that no one wanted to admit existed. The aircraft staging began well before the first rotor turned. Both Chinooks were loaded into a single C-5 Galaxy, flown first to Germany for final calibration checks, and then to the Chadian capital of N'Djamena. The French government provided logistical clearance and stationed Mirage F-1 fighters at the edge of the air route. A C-130 Hercules joined the support chain, landing at forward refueling points that would later allow non-stop return flights. An advanced reconnaissance element had been in country for nearly 2 weeks, logging routes, measuring distances under prevailing wind, and marking emergency landing strips in the sand. The operation divided into two crews, known as Chalk 1 and Chalk 2. Chalk 1 would move first to Awadi Dome, a Libyan-built airfield captured months earlier and now abandoned except for scattered equipment. Their task was simple but hazardous: secure the site, clear obstructions, and prepare the Mi-25 Hind D for transport. The gunship still stood near the ramp where Libyan forces had left it, its camouflage dulled by exposure but structure intact. Working within the range of potential patrols, the team removed the rotor blades, drained residual fuel, and reinforced the attachment hardpoints where the sling harness would connect. Radio silence remained absolute. Every command moved by gesture or light signal. Chalk 2 followed after midnight, the lifting Chinook flying with navigation lights disabled, its crew guided by night vision imagery sharpened by earlier training in New Mexico. Hovering over the airfield only long enough to attach the load, they brought the cables taut, confirmed weight equalization, and eased power until the nose wheel of the Hind cleared the ground. Within minutes, the combined aircraft were airborne again, swinging south. The schedule allowed 67 hours from insertion to extraction before either satellite or diplomatic channels could alert nearby governments. 2 in-flight refuelings punctuated the transit. Each required precision timing since any delay risked daylight exposure. The sandstorm arrived just after the second refueling, a column of suspended grit rising roughly 3,000 feet and masking the horizon to nothing. Chalk 2 pressed forward rather than hold, relying entirely on instruments and inertial drift correction. Airspeed dropped to maintain rotor stability, which forced fuel calculations down to reserve margins. Cockpit voice logs later described heat shimmers so intense that the Chinook's own lights reflected backward into the cabin. Still, the load held. They landed at N'Djamena minutes before the storm's centerline arrived. Visibility was near zero as they shut down and waited 20 minutes for the sky to settle enough to begin final loading. Within that brief lull, the captured Hind rolled into the C-5's cargo bay, lashed for intercontinental transport. The total flight time reached roughly 36 hours, with the crews and aircraft returning intact. For the 161st Night Stalkers, Mount Hope 3 validated practice by performance and turned a theoretical recovery into executed aviation strategy, an act of logistics carried out under the quiet camouflage of precision. Mount Hope 3 demonstrated that intelligence victories often hinge on logistics rather than confrontation. Its success came from a mindset where calculation replaced chance, and each rehearsal turned complexity into routine. The operation showed how disciplined preparation could reshape the limits of special aviation without firing a weapon. That same principle defines modern special operations today. Missions begin long before deployment, perfected in test ranges under controlled stress until results become predictable. The unseen groundwork, hours of technical validation and simulation, forms the quiet margin that determines success. Every smooth extraction traces its origin to that invisible rehearsal floor,